Welcome to Systemic Stack. My name is Kabir Anand. This is episode 11 of the System Engineering series, and today we will explore SLA, SLO, SLIs in a way that helps you prepare for system engineering interviews on this topic. Well, these metrics are the bridge between business promises and actual system performance. Showing an interviewer you can define clear SLIs and manage error budgets proves you've got a handle on operational reality. We'll look at how to pick the right indicators so you can defend your reliability choices with confidence. This lesson starts by framing reliability as a measurable spectrum rather than a binary up or down state. You will see how service level management bridges the gap between business needs and technical capabilities, moving us from intuition to actual engineering. We are going to break down the specific hierarchy of SLAs, SLOs, and SLIs, which is often where interview candidates trip up. You'll learn why it's critical to differentiate between a contractual promise made to users and the stricter internal targets your team uses to keep things running smoothly. From there, we dive into the core metrics that drive these decisions, focusing on things like latency percentiles, error rates, and the classic nines of reliability. Well, it is not only about the definitions, it's about understanding how these numbers represent the actual user experience, right? Finally, we'll map these concepts together and analyze a real-world cloud SLA case study to see how exclusions and credits work in practice. By the end, you will understand how to justify reliability targets and technical metrics with the precision needed for a high-level system design interview. When we talk about the pillars of reliability, we are really talking about a shared language. In many organizations, a major failure mode occurs because engineers and business stakeholders aren't speaking the same dialect. The engineer says the database is slow, but the business lead wants to know if they're losing money. Mastering these terms allows you to bridge that gap. What matters here is that without this framework, you're just guessing at how much to invest in infrastructure. If you over-engineer for 100% uptime, you waste millions. If you under-engineer, you lose users. In an interview, the recruiter is looking for this nuanced understanding of balance. They want to see that you don't just want things to be perfect, you want them to be appropriately reliable. If you can't measure performance, you can't manage it, and you certainly can't improve it. So think of these pillars as the skeleton of your operational strategy. They provide the structure that allows a service to grow and scale without collapsing under its own complexity or failing to meet user expectations. Reliability engineering isn't just a set of tasks, it's a mindset that acts as a bridge. On one side, you have business needs like feature velocity and market growth, and on the other, you have technical capabilities like server capacity and network latency. The bridge between them is service level management. Now, why does this matter? Well, if you push features too fast without a reliability framework, your system breaks. If you focus only on stability, your product stalls. A major failure mode here is the silo effect, where developers don't care about reliability and SREs don't care about features. By using SLAs and SLOs, we create a common ground where both sides agree on a threshold of pain. This is a huge signal in interviews. If you're asked how to handle a team that keeps breaking production, you don't just say test more. You talk about building a foundation of reliability where data-driven targets dictate when it's safe to ship and when you need to freeze features to fix the core system. One of the first things to realize is that reliability is not a binary state. Your system isn't just up or down in the way we often imagine. It's actually a measurable spectrum. Moving from intuition to engineering means we stop saying the site feels sluggish and start saying the 95th percentile latency is at 350 milliseconds. This distinction is vital because human intuition is notoriously bad at catching slow regressions. A system can be slowly dying for weeks before anyone notices if you aren't tracking quantitative goals. In a system design interview, if you're asked about monitoring, don't just list tools like Prometheus or Datadog. Instead, explain that you need these quantitative goals to define what good looks like. A failure mode to watch out for is vanity metrics, where you measure things that look great on a dashboard but don't actually reflect the user's experience. You need to focus on metrics that correlate with actual user frustration or success, moving beyond gut feelings into the realm of hard, actionable engineering data. Let's start with the SLA, or the Service Level Agreement. This is the external promise. Think of it as a contract between a service provider and a customer. It's not just a technical goal. It's a legal and financial document that outlines what happens if you fail. If you promise 3 nines of availability and you hit 2, the SLA dictates the consequences, usually in the form of service credits or refunds. What matters here is that it sets the stakes for the entire organization. However, a huge failure mode is setting an SLA that's too high. If you promise 99.99%, but your underlying cloud provider only guarantees 99.9%, you've just created a massive financial liability. In an interview, show you understand this business technical alignment. You'd never set your SLA at the same level as your internal targets. You always need a buffer. The SLA is the absolute floor, the point where the business starts losing money and reputation. It's the external commitment that forces the technical team to maintain a certain standard of excellence to keep the company viable. Moving inside the company, we have the SLO or service level objective. This is the internal target set by the engineering team, and it's almost always stricter than the SLA. If your SLA is 99.9%, your SLO might be 99.95%. This gap is your safety margin or buffer. Why does this matter? Because it gives you an early warning system. If you breach your SLO, you're in trouble internally, but you haven't yet violated your contract with the customer. This leads us to one of the most important concepts in modern engineering, the error budget. If you meet your SLO, you have credit to take risks and ship new features. If you burn through that budget because of outages, you stop and focus on stability. A common failure mode is ignoring the SLO until the SLA is already breached. In an interview, you'll want to emphasize that SLOs are the heartbeat of the dev cycle. They tell the team when they are moving too fast and when they have room to experiment, keeping the system healthy before the lawyers have to get involved. To have an SLO, you need an SLI, which is the service level indicator. This is the raw, quantitative measure of some aspect of the service. If the SLO is the goal, the SLI is the thermometer. For example, if your goal is to be fast, your SLI might be the latency of successful homepage requests. You have to be very specific here. What matters here is that if your SLIs are poorly defined, your SLOs become meaningless. A classic failure mode is measuring the wrong thing, like looking at CPU usage instead of request success rate. Your users don't care if the CPU is at 10% if they're getting 500 errors. In an interview, when you're asked how to monitor a system, start with the SLIs that reflect user experience. You want to track the work the system is actually doing for the user, not just the health of the individual machines. It's the difference between knowing the engine is running and knowing the car is actually moving the passenger toward their destination at the expected speed. Latency is one of the most common SLIs, but it's also one where people make the most mistakes. When we talk about latency, we are measuring the time it takes for a system to process a request. The biggest trap you can fall into in an interview is talking about average latency. Averages are dangerous because they hide the outliers. If 9 users have a 10 millisecond response and the 10th user has a 10-second response, the average looks fine, but that 10th user is having a terrible experience. That's why we use percentiles like P95 or P99. This tells us the experience of the slowest 5% or 1% of users. What matters here is that it captures the long tail where the real system bottlenecks live. A failure mode here is ignoring the P99s until they start dragging down your overall metrics. High percentile latency usually points to resource contention, garbage collection pauses, or network congestion. When you explain this in an interview, you're signaling that you understand the reality of distributed systems, where the worst-case scenario is what actually defines your system's perceived reliability. Next up is the error rate, which is the ratio of failed requests to total requests. On the surface, it seems simple. Count the 500 errors and divide by total traffic. But in a real-world system, it's more complex. You have explicit errors like an HTTP 500, but you also have implicit errors. These are the silent killers, where the system returns a 200 OK, but sends back an empty body or corrupted data. Why does this matter? Well, if your monitoring only looks at status codes, you might think everything is green while your users are seeing blank screens. This is a classic failure mode in complex architectures. In an interview, you should talk about how you define a fail request. Does a 404 count? Usually not, because that's often a user error, but a 503 definitely counts. Distinguishing between client-side errors and server-side failures is key to building an accurate SLI. You want your error rate to reflect the actual reliability of your code and infrastructure, not just the fact that people are typing in wrong URLs. Availability is the metric everyone talks about, often expressed in nines. 99.9% availability sounds great, but it still allows for nearly 9 hours of downtime a year. If you move to 4 nines, you only have about 52 minutes. What matters here is that each 9 you add exponentially increases the cost and complexity of your architecture. You might need multi-region failover, more redundancy, and faster automated recovery. A major failure mode is focusing only on time-based availability, meaning the system is up while ignoring partial outages. If your service is up but the database is in read-only mode, are you really available? In an interview, show that you understand these trade-offs. More nines isn't always better if the cost of achieving them outweighs the business value. You have to find the sweet spot where the system is reliable enough that users stay happy, but you aren't spending your entire engineering budget on chasing a decimal point that doesn't actually change the user's perception of the service. Now, let's map how these three work together. It's a hierarchy. Your SLIs are the raw data points flowing from your servers. You aggregate those SLIs into SLOs, which are your internal targets for what those metrics should look like over a period of time, like a rolling 30-day window. Then those SLOs inform the SLAs you sign with your customers. This relationship ensures that your technical metrics are directly aligned with your business commitments. If they aren't aligned, you'll run into a massive failure mode, the watermelon effect. This is where your internal dashboards are all green, but the customer is seeing red. It happens when you're measuring the wrong things or setting the wrong targets. In an interview, explain that a robust system architecture isn't just about the code, it's about this flow of information. You need to be able to justify an architecture choice by showing how it helps you hit an SLI, which protects an SLO, which ultimately keeps you from breaching an SLA and losing money. To see how this works in the real world, we can look at a typical cloud SLA. If you read the fine print, you'll see it's rarely a simple up or down guarantee. They include exclusion clauses like scheduled maintenance or issues caused by the user's own code. They also define exactly how they calculate service credits. If the uptime drops below a certain point, you get 10% back. If it drops further, you get 25%. What matters here is that it shows that SLAs are about risk management, not just technical perfection. A common failure mode for developers is assuming a 4 nines SLA means they never have to worry about downtime. In reality, you have to design your system to be more resilient than the underlying services it relies on. In an interview, if you're asked about using a third-party API, you should mention checking their SLA and then building a fallback mechanism for when they inevitably breach it. You can't outsource your own reliability. You have to plan for the failure of every component in your stack. We've just laid out the entire hierarchy of reliability engineering. And honestly, mastering these three pillars is how you separate vague intuition from real systems design. You've got your SLIs, those raw metrics like P99 latency or error rates that tell you exactly what's happening on the ground. Then there's the SLO, which is your internal line in the sand. When you're in an interview, make sure you emphasize that your SLO should always be tighter than your SLA. That gap is your safety margin. It's the buffer that lets you fix issues before they become a legal or financial headache. We also looked at how error budgets turn these abstract goals into a practical tool for deciding when to ship features or focus on stability. So by tying these together, you're not just monitoring a dashboard, you're actually engineering reliability into the business model. That's how you maintain a high-performing system without burning out your team. So that wraps up our breakdown of SLAs, SLOs, and SLIs. When you're in an interview, try to focus on how these metrics actually drive engineering decisions. You'll want to explain, for example, how P99 latency captures the experience of your most frustrated users and how that feeds into the error budget to manage risk. Showing that you understand the tension between feature speed and system reliability is a huge signal for interviewers. For more, check the course details in the description and hit subscribe to stay ahead. In the next episode, we will discuss idempotency basics, where we'll discuss core understanding, definition, importance. Good luck with your preparation.